Good day. We discussed the term 2 past year in 2023, question 19. First question, state Faraday's law. So this is what we learned. When there is change in magnetic flux linked with a conductor, there is an induced EMF in the conductor, which is directly proportional to the rate of change of magnetic flux linkage. Okay, so this is a very important definition that provide us the first formula in almost all the questions in this chapter. Second, explain the phenomenon of self-induction. Okay, also what we have learned. A phenomenon in which back EMF is induced in the inductor when there is change in current flowing in the inductor. So 3 marks, we try to explain more. When the switch is closed, there's increase in current flow and also the magnetic flux linked to the inductor. So there is back EMF to oppose the increase in magnetic flux. Now I move to the next question. State 3 ways to change the magnetic flux of a coil in a uniform magnetic field. So the question already mentioned uniform magnetic field. So I don't think you can mention to change the magnetic field strength to change the magnetic flux. So we're going to review back the formula of the flux is NBA cos theta. So there are other 3 variables that we can change to change the magnetic flux. So it is either we're going to change the number of turns of coil, or we're going to change the radius of the coil, which influence the area of the coil. And lastly, okay, we're going to change the angle, okay, the cos theta, which is the angle between the field and also the normal of the coil, is by rotate the coil. Okay, so that's the 3 ways to change the magnetic flux. We move on to question D. So this question maybe a little, there's some discussion. Okay, let us see what is the problem. Okay, a magnetic bar is moved perpendicularly toward a single conducting loop in 3 stages, 1, 2, 3, as shown in the graph. So first one, calculate the induced EMF in stage 1, 2, 3. So how we can calculate the induced EMF? Okay, so what we have learned about Faraday's law, E is equal to dV dt, and V is equal to NBA. So it mentioned a single conducting loop, so the number of turns is equal to 1. Okay, but okay, we don't have the area. Okay, so that's the problem of this question. So no matter what it is, okay, we only can assume that maybe the area is 1, okay, because it's not proper. Okay, if you want to assume area is 2, 3, 4, or maybe there is other ways to find it. Okay, if you know, you can leave it in the comment section. Let me know about it. So what I can say is we want to determine the EMF. We're going to use the formula of area dB dt. Okay, so this the derived formula to solve this question. Okay, but without the area, okay, so this answer is just assume that the area is equal to 1. So we're going to calculate the gradient of the graph, okay, which represent the dB dt. Multiply area is the EMF. Okay, so stage 1, 0.2 volt, stage 2, 0 volt. Okay, there's no change. And stage 3 is negative 0.1 volt. So I think we just discussed up to this point. Let's look at the last question. Determine the magnitude of an induced current in stage 1 if the resistance of the loop is 5 ohm. Simple. Okay, if we have the induced EMF, okay, which is the voltage, okay, we just apply the Ohm's law, V equal to IR. Okay, so we have the voltage in stage 1 is 0.2 volt. Okay, assume that the area is equal to 1. IR, okay, R is 5. So from here, current is 0.04 ampere. So in summary, I think that you know the ways how to solve it, okay, even though there may be a problem in the question, okay, but I think that's the things that you can learn from this question. So that's all for this question. Thank you.